So in this question, you need to find like the equivalent capacitance between A and B. Okay, you just connect a cell in between A and B because you need to find the equivalent capacitance between A and B. All right. Now, first step to solve such question: mark all the junction. Just mark. This is P, junction Q, junction R, junction S. Next
Yes,
step
sir.
is equivalent capacitance. We need to find. This is C, C, C. Next step is redraw the circuit. What their next step is what? Redraw the circuit with all the junction having same potential will be represented by a single point. Okay. Now we need to check like which junction is having the same potential. Now this is V, this is 0. So here also V, here also V, same potential V, V, V at R, V. Understood? Here also V,
Yeah.
here also V. Understood? 0, 0, here also 0 volt, 0 volt. Now this is connecting this Q point. Q point is also having 0 volt.
0.
0, 0. Now see, this P and R is having the same voltage.
Yeah, sir.
What? That is V.
Hmm.
Any other like point which is having the same voltage, A also. But A is not a junction, first of all. Clear? Understood?
Yeah, sir.
Next, you can see 0. 0 is Q. Q and S. Q and S is having 0 volt. Clear?
Yeah, sir.
Now what they are saying? Next third step is now connect all the capacitor between the points. Now see. V0. This capacitor. Now connect all the capacitor. How many capacitors? 3. Simple connect. Okay. Clear? Any doubt?
No, sir.
See, A is also having V voltage. So I can say A is here. And B is also having like 0 volt. I can assume here B. Understood? Simply find in parallel what is the equivalent now. Tell me fast. This is C. C, C. What is the equivalent in parallel now?
3C.
How much?
3C.
Very good. C plus C plus C, that is 3C. So again I am saying simply 3 step. First, mark all the junction. Redraw the circuit with all the junction having the same potential
Same
will be
potential.
represented by a single point.
Okay,
Here,
sir.
after this, now connect all the capacitor. Whatever capacitor you are looking, just connect. Here, now connect all the capacitor between the points. Here, in those
Yeah, sir.
2 points, whatever points you have marked, in between that, just connect all the capacitor. That's all. Here,
Yeah, sir.
without like. So this is
No,
known
sir.
as common potential method. This is what we are learning. This is common potential method. Common potential.
This method we'll use when there are wires that are between the capacitors, right, sir? Like
Simply like this method we should use when potential is common. Like junction, for example, 2 junction is having the same potential. Okay, so just a simplification method. Okay, it's a simplification method, nothing else.
okay, sir.
And if you want to go in depth, you just look at this. Here V, here also V. In this capacitor, here potential difference is V minus 0. Here also V minus 0. Here also V minus 0. Same potential. It means they are in parallel. If I am not using this method, then how will you identify how they are in parallel? If I redraw the circuit, then it looks good now.
It looks like it is in series only, but it is not.
Yes, yes, yes. That's why it is a simplification method.
Okay, sir.
Simplification. That's why I'm teaching these methods to you.
Mm,
So there are
mm,
several methods. Okay, there are several methods to solve or to simplify our problem. You can apply this the
mm,
same method in resistance problem also. In place of C, you can
mm,
find resistors also. Understood?
mm.
Any
Yeah, sir.
doubt? Is it clear line?
Yes.
100%
Mm,
clear?
yeah, sir.
Okay.